Today's CRD-equipped passenger vehicles have complex exhaust after-treatment systems that must be understood, serviced, repaired or replaced by proficient service technicians. The new CRD ECM not only monitors engine functions, but it must now oversee the operation of complex exhaust emission control as well. Today's automotive service and repair technicians are now challenged with diagnosing faults within these evolving systems. In this video, we'll focus on the diagnostics of the exhaust emission management system, the replacement of DPFs and their like components. We'll also cover in detail the forced regeneration process that occurs in today's CRD passenger vehicles. Just like the engine management system, an exhaust emission warning light may be illuminated to inform the driver of key events that may be occurring while the vehicle is operating. Often, passive and active regenerations occur in a CRD vehicle without the driver noticing any change in performance. The warning lamp may illuminate when exhaust emission parameters fall outside their control limits, or when a regeneration event has been interrupted. This warning is used to inform the driver that the DPF is in a fault or error state and that the vehicle must be driven in an appropriate manner or drive cycle that will clear the soot accumulation within the particulate filter. The owner's manual describes how the vehicle must be driven with cautions and warnings appropriate for this type of regeneration process. If the warning lamp does not extinguish during this specific drive cycle, the driver or vehicle owner must arrange to take the vehicle to a service repair centre for further diagnosis and investigation. The malfunction indicator lamp, or MIL, may also illuminate to indicate there is a fault within the DPF or associated components. This may result in the ECM entering a reduced power mode. A proficient technician will need all available information to assist with diagnosis. Freeze frame failure records associated with any stored DTCs should be referred to when diagnosing intermittent faults. Exhaust after-treatment data is invaluable when evaluating previous DPF regeneration events. These may include distance travelled since last regeneration, vehicle runtime, exhaust temperatures, and so on. Faults within the intake, injection, EGR or turbocharger and exhaust systems may trigger DPF-related DTCs. If a mass airflow sensor code is recorded alongside a DPF flow code, always investigate the MAF code first. When looking for the cause of DPF-related DTCs, perform a visual inspection of the DPF pressure and EGT sensors for security or impairment. Inspect any sensor pipes, hoses or connections for leaks and damage. Check all electrical connectors for backed out terminals, corrosion, water ingress and security. Inspect the exhaust system for leaks or visible damage that may influence exhaust gas flow. Pay close attention to the DPF itself and ensure that there is no soot leaking from the filter. Any leaks here will cause an incorrect differential pressure reading, resulting in DTCs. Don't forget to inspect the engine coolant and oil levels. A leaking head gasket may allow coolant or engine oil to enter and contaminate the DPF substrate, preventing passive or active regeneration events, resulting in high soot accumulation levels and subsequent flow-related DTCs. Once all preliminary inspections have been made and no obvious faults are being found, it will be necessary to analyse the DPF pressure sensor values. The manufacturer of this vehicle recommends a maximum pressure difference across the DPF of 10 kPa. If a substantially higher value is present and there are no circuit fault DTCs logged, then the soot accumulation level in the DPF is high enough to warrant a forced regeneration. If the value was lower than 1 kPa, a regeneration is not required. This value would indicate a DPF with significant damage to the substrate, allowing exhaust gas to flow through with no restriction. It's vital to differentiate between a DPF flow DTC and a pressure sensor circuit fault when performing a diagnosis. The results of this will dictate whether electrical testing is performed or a forced regeneration needs to be carried out. If you have confirmed that there are no exhaust leaks, mechanical faults, or problems in the electrical system, and the exhaust after treatment data suggests a high level of soot concentration, only then is it time to perform a forced regeneration. When commanded by the scan tool, you may be prompted to raise the engine's coolant temperature to a minimum safe level. This may mean a road test is required, or the engine speed will need to be held above a fast idle for a period of time. It's best practice when performing a forced regeneration to have the handbrake locked on, the transmission in park, and the vehicle located in a well-ventilated area and on a level, non-flammable surface. When the conditions for running the forced regeneration are met and the start button is pressed, the ECM will increase the engine speed to a predetermined level. To burn the diesel particulates trapped within the substrate material, the exhaust temperature must be raised to around 600 degrees Celsius. It's during this time that the ECM commences post-fuel injection events to increase the exhaust gas temperature. If the ECM detects that the exhaust gas temperature has risen above a safe operating level, the forced regeneration will be aborted. The forced regeneration procedure may take around 20 minutes to complete, depending on the severity of the soot accumulation within the DPF. Once the ECM has determined that the particulate level has fallen below acceptable limits, the forced regeneration event will be finalised and the engine RPMs will subside. This may involve a cool-down period where temperatures and engine speed are reduced slowly. You may be prompted to perform a DPF pressure reset. This simply tells the ECM what the new base pressure values are. Don't leave the vehicle unattended during a forced regeneration. If any major problems occur, you must be able to switch the ignition off to prevent engine and exhaust damage. An engine oil change may be necessary after running the forced regeneration. The oil viscosity will be reduced and the level may increase due to the extra fuel injected during the DPF regeneration process. It's best practice to replace the engine oil if the vehicle is close to its service interval, or if it's taken more than 3 forced regenerations to reduce the soot accumulation. CRD vehicles fitted with DPFs require the use of low ash engine oil. When replacing or topping engine oil, only low ash oil complying with the viscosity and specifications stated in the owner's manual must be used. If the incorrect engine oil is used, ash, which is more dense than soot, will accumulate in the DPF, which in turn reduces the total DPF capacity. Ash cannot be burnt off and can severely reduce the life of the DPF and associated components. If the DPF has become blocked after a recent oil change and the type of oil used cannot be determined, then it's imperative to replace with manufacturer specified or approved oil. Failure to do so will result in the replacement DPF clogging up within a short time and may affect warranty. If it becomes necessary to replace the DPF based on multiple unsuccessful forced regenerations, internal DPF damage, or substrate contamination, there are several key steps that must be followed. Make sure the exhaust system has cooled sufficiently and all required personal protective equipment is worn. Follow the manufacturer's specified procedure when replacing and installing the new DPF assembly. Be sure to tighten all fasteners to the correct torque to prevent damage or premature component failure. Now that we've installed a quality Ryco particulate filter, we need to reset the ECM stored DPF load values. This can be done by accessing the engine control functions within the Scan Tools menu and following all on-screen instructions. Always perform a road test after any DPF replacement. Ensure the vehicle has been subjected to the correct drive cycle applicable to the logged DTC. Be confident when diagnosing DPF faults. Understand how the system operates, follow the manufacturer's procedures, and you'll avoid component misdiagnosis. Thanks for watching.